Hello Tweezer people! Is this magic? No, it's static electricity. You probably have heard us talking about ESD tweezers thousands of times, but what does it really mean? Today we will try to easily explain this technical aspect. In everyday life, all of us have already experienced static electricity or little shocks, or electrostatic discharge, ESD. For example, when touching a metal doorknob after walking across a carpeted floor. The electrons cling to your body until they can be released. As you reach and touch an object, you get a shock as the surplus electrons are being released. That's quite annoying in ordinary circumstances, or funny if you want to entertain your children. But in specific workplaces, it can also be costly and dangerous. Our body cannot even experience any ESD event unless there is a shock of 2,000–3,000 volts, while sensitive components could be damaged by ESD event with 100 volts or even less. This static discharge can damage electronic components, attract contaminants in cleanroom environments, or cause products to stick together. Electronic devices, circuitries can be permanently and immediately damaged, causing the device stop working totally or partially. But the more worrying subtle effect is the latent damage. It is very difficult to identify as the device may keep on performing its task, but its operating life is drastically reduced. As you can imagine, we're talking about only wasting few cents for a simple diode or thousands of dollars for complex circuits. To prevent this kind of issues, you don't need a single tool, but a complete system including precautions, grounding mechanism, and a lack of highly charged materials. In this way, you defined an electrostatic discharge protection area to keep electrostatic discharge sensitive materials safe. ESD-safe tweezers equalize the differences in electrical potential between their users and the workpieces in a controlled manner. They will not prevent static discharge, but they will limit the peak current at which this occurs, which can be enough to save some components from destructions. These tweezers have a balanced charge and a low surface resistivity, which means they don't gain or lose charge to the objects and surfaces that surround them. Put it simply, it means that if the operator is charged for some reason, for example is not wearing a strap, pick up the tool and touch a component, the charge will equalize slowly and will not damage the component. On the contrary, a quick discharge would damage it. It's important to anticipate this kind of events because employees are usually a prime cause of electrostatic discharge during assembly and reworking. In Ideal Tech, our testing procedure is based on strict standard, as since the 90s we have been developing tweezers materials and coatings to meet the ESD parameters as requested, for example, by the disk drive industry. The most common ESD-safe coatings are the epoxy coating, the rubber, the foam, while the most common ESD-safe material are black ceramic tweezers, full plastic, and plastic tip tweezers. One of our main references in the field is the American ESD Association. Have a look at their website for more technical information about the topic. And with us, stay tuned.